Good day, class! For today's discussion, we will be covering the key topics included in our middle term. We will be dividing into some fundamental concepts in geometry that are essential for understanding and how shape relate and how we can prove those relationships with logical reasoning. We'll begin with conditional statements under converses, which are the foundation of mathematical proofs. And then, we'll explore the triangle congruence postulates and the right triangle congruence theorems, tools that helps us establish when two triangles are exactly the same in shape and size. And along the way, we'll also discuss the effective steps and techniques in proving congruence. By mastering these concepts, we strengthen our ability to think critically, reason logically, and communicate mathematically ideas with clarity. So now, let's begin.
A theorem is a statement that needs to be proven. This emphasizes that theorems are not just random facts. They are mathematical truths that have been rigorously demonstrated to be true through logical reasoning and evidence. An if-then statement, or also known as a conditional statement, is a logical statement that asserts that if the condition or the if part is true, then the consequence, the then part, will also be true. This clearly explains the relationship between the hypothesis or the if part and the conclusion or the then part. So example of an if and then statement. First is, we have, if it is a right triangle, then it has one right angle. So this example clearly illustrates the if part or being a right triangle as a condition and the then part or having one right angle as the consequence. It is a simple and understandable example to solidify the concept of a conditional statement. So second is, if there are 2 points, then they determine a line. So this introduces another example from geometry. So the condition is, there are 2 points and the consequence is, they determine a line. So this illustrates how if-then statements can express fundamental geometric principles. So the third one is, if a parallelogram is a rectangle, then it has one right angle. So this introduces a statement about the properties of quadrilaterals. The condition is a parallelogram is a rectangle, and the consequence is it has one right angle. So this statement is actually false as a rectangle has 4 right angles. So the fourth example is, if the measure of the angle is equal to 90 degrees, then it is a right angle. So this provides a definition of a right angle in the form of an if and then statement. The condition is the measure of the angle is equal to 90 degrees and the consequence is it is a right angle. This statement is true by definition. Illustration of a right angle. So right angle identifies the subject of the illustration. So the image shows an angle formed by 2 rays meeting at a vertex. A small square symbol is placed in the corner of the angle, which is the standard notation to denote a 90 degrees or right angle. The label 90 degrees further clarifies the measure of the angle.
Now, let's talk about converse. If the original if-then statement is reversed, then the resulting statement becomes a converse. A converse is a theorem in reverse when a theorem is written in the if-then format. The then statement will be the if statement. In the converse of a theorem, the if-then statements are swapped. Here are some examples of if-then statements to converse. So the first example is, in if-then statement, if there are 2 points, then they determine a line. In converse, if there is a line, then there are 2 points that determine it. The second example is, in if-then statement, if it is a quadrilateral, then it is determined by 4 coplanar and non-collinear points. In converse, if it is determined by 4 coplanar and non-collinear points, then it is quadrilateral. The third example is, in if-then statement, if a parallelogram is a rectangle, then it has one right angle. In converse, if it has one right angle, then the parallelogram is a rectangle. The fourth example is, if the measure of the angle is equal to 90 degrees, then it is a right angle. In converse, if it is a right angle, then its measure is equal to 90 degrees. The fifth example is, in the if-then statement, if a quadrilateral is a square, then it has 4 equal length sides. In converse, if a quadrilateral has 4 equal length sides, then it is a square. So those are some examples of if-then statement to converse.
Today, I will be discussing a fundamental concept in geometry, the triangle congruence postulates. These postulates help us determine when two triangles are exactly the same in size and shape. In other words, when they are congruent. So what is congruence in triangles? Congruent triangles are triangles that have the same size and shapes. This means that their corresponding sides are equal in length and their corresponding angles are equal in measure. We use triangle congruence postulates to prove that two triangles are congruent without having to measure all 6 parts. There are several important postulates that allow us to prove triangle congruence. First is the SSS postulate, or the side-side-side postulate. If 3 sides of one triangle are congruent to 3 sides of another triangle, then the two triangles are congruent. Next is the SAS postulate, or the side-angle side. States that if 2 sides and an included angle of one triangle are congruent to the corresponding 2 sides and an included angle of the other triangle, then the triangles are congruent. Angle-side-angle postulate. If 2 angles and an included side of one triangle are congruent to the corresponding 2 angles and an included side of another triangle, then the triangles are congruent. The angle-angle side, or the AAS postulate, was proven using the triangle congruent postulate. It states that if 2 angles and the non-included side of one triangle are congruent, respectively, to the corresponding angles and non-included side of another triangle, then the two triangles are congruent. So next is the right triangle congruence. A plane figure bounded by 3 finite line segments to form a closed figure is known as a triangle. A right-angled triangle is a special case of the triangle. In a right-angled triangle, one of the interior angles measures 90 degrees. 2 right triangles are said to be congruent if they are of the same shape and size. In other words, 2 right triangles are said to be congruent if the measure of the length of their corresponding sides and their corresponding angles is equal.
The process of proving triangle congruence generally follows a logical sequence of steps. Let's break them down. First, determine the corresponding parts, vertices, angles, and sides. The first crucial step is to identify the corresponding parts of the 2 triangles you are comparing. This means carefully matching up the vertices, the angles, and the sides line segments connecting the vertices. Second one, decide on what congruence postulate or theorem is applicable. Once we know the corresponding parts, the next step is to decide which congruence postulate or theorem applies to the given information. These are the established rules that tell us when 2 triangles are congruent based on the relationship between their sides and angles. Some of the key postulates and theorems include side-side-side, or we call as SSS, side-angle-side, or we call as SAS or SAS. One is angle-side-angle, the ASA, and the fourth one, or the letting go this as. And we have also the right triangle theorem. So we move on to the third step. Use the two-column method or proof. To formally prove the congruence, we often use a two-column method or proof. This helps organize our statements and the reasons that support them in a clear and logical way. Next, build the next statement from the results or conclusion from the given, if possible. In the proof, we start with what is given in the problem, the initial conditions or facts we know to be true. Then, we build the next statement based on these given facts using definitions, properties, postulates, or theorems. We continue this process, repeating steps 4 through 6 until we have logically shown that all the necessary corresponding parts satisfy the conditions of the chosen congruence, postulate, or theorem. Each statement in the left column must be supported by a valid reason in the right column. Tick marks or hash marks may be used to indicate proven corresponding congruent parts of the triangle for guides. One helpful visual aid often used when working with triangle congruence is the use of the tick marks or hash marks. These marks are placed on the sides and angles of the triangles to indicate which corresponding parts are congruent.
Congruence of triangles. The vertices, sides, and angles of the triangle can be paired in a one-to-one correspondence. An order is of great importance. The order can be clockwise or counterclockwise. The length of sides and angle measures shall be considered. Basic ideas on congruence. Congruence is a basic geometric relationship. It is the quality of agreeing, coinciding, or the state of being congruent. Denotes a harmonious relationship between two or more senses or objects. An agreement and correspondence between or among parts of these objects. For example, segment ME is congruent to segment YO. Shapes and figures are congruent if their corresponding sides and angles are congruent. It should be denoted that they have the same number of sides and vertices. For example, pentagon cards is congruent to pentagon Shopee. Corresponding congruent parts, sides. Segment BL is congruent to segment RA. Segment LU is congruent to segment ED. Segment UB is congruent to segment DR. Angles. We have angle BLU is congruent to angle RED. Angle LUB is congruent to angle EDR and angle UBL is congruent to angle DRE. Triangle congruence postulates. There are three postulates that can be useful in proving triangle congruence. First, we have side postulate. It states that if three sides of one triangle are congruent to the corresponding three sides of the other triangle, then the two triangles are congruent. Next, we have side postulate. States that if two sides and included angle of one triangle are congruent to the corresponding two sides and included angle of the other triangle, then the two triangles are congruent. You can use tick marks or hash marks to indicate proven corresponding congruent parts of the triangle. Then, the third one is side angle postulates. State that if two angles and included side of one triangle are congruent to the corresponding two angles and included side of another triangle, then the two triangles are congruent. Side congruence postulates was proven using the triangle congruence postulates. It states that if two angles and non-included side of one triangle are congruent respectively to the corresponding angles and non-included side of another triangle, then the two triangles are congruent. The right triangle congruence theorem. The sides of the right triangle are the legs and hypotenuse. The legs are the two perpendicular sides and hypotenuse is the longest side of the right triangle. There are four right triangle congruence theorems that can be used in proving congruence between two right triangles. First, we have leg-leg congruence theorem. States that if the two legs of one right triangle are congruent to the corresponding two legs of the other triangle, then the two triangles are congruent. The second one is leg angle. If a leg and acute angle of one right triangle are congruent to a leg and acute angle of another right triangle, then the two right triangles are congruent. The third one is hypotenuse angle congruence theorem. If an acute angle and hypotenuse of one right triangle are congruent to an acute angle and hypotenuse of another right triangle, then the triangles are congruent. The last one, we have hypotenuse leg congruence theorem. If a leg and hypotenuse of one right triangle are congruent to a corresponding leg and hypotenuse of another right triangle, then the two right triangles are congruent. Those postulates and theorems are useful in proving congruence between two triangles.
So that's the end of our discussion for the midterm on important concepts in geometry. I hope you learned something today. Goodbye for now, class, and thank you for listening.